Okay, this is stats, and we're going to do part 2 of section 1.2. And in part 2, we're going to cover make and interpret histograms of quantitative data and compare distributions of quantitative data. So to start, we have quantitative variables often take up many values. A graph of the distribution may be clear if nearby values are grouped together. So histograms are a little bit different. So once you see the difference, hopefully it'll sink in. How to make a histogram: divide the range of data into classes of equal width. Find the count, or frequency, or percent relatively frequency of individuals in each class. Label and scale your axes and draw the histogram. The height of the bar equals its frequency. Adjacent bars should touch unless the class contains no individuals. So I'll explain that when I get to it. So let's take the first one. You have, let's see, foreign-born residents. So what percentage of your home estate residents were born outside the United States? A few years ago, country as a whole had 12.5% of foreign-born, but the states varied from 1.2 to 27.2 in California, which makes sense. We have some states that have a lot more foreign-born than not. So the variable is the percent. I'm going to highlight this part so you can actually see it. Okay, the variable is the percent of the state's residents who are foreign-born. It should be. Okay, fine. The variable is the percent of the state's residents who are foreign-born. It's much easier to see from a graph than from the table how your states compare with other states. So looking at this, I agree with them. I can't make heads or tails. I can probably tell you, okay, I understand that, 2.9 or 2.8 is really low and 20 something is probably in the high. But it's easier to when we do it with the graph. So here are the steps in making the histogram. Number 1, divide the data into classes of equal width. So what they mean by this is, since it ranges from 1.2, and from 1.2 I mean by down here in West Virginia, this is going to be the smallest number that we have. It ranges from 1.2 to 27.2, which is, where's 27.2? California. Okay. We might choose to use classes of width of 5 beginning at 0. So from 0 to 5, I would put the 1.2 into this grouping right over here. I would put 27.2 into the last grouping of 25 to 30, and so on and so forth. So everyone should fall within a certain category from 0 to 5, 5 to 10, and so on and so forth. If you have something that's exactly at 5.0, for example, that's what it says in here. Let's say you had a state that had a 5.0%, right? Then you actually put it into the 5 to 10, because the widths that you're about to do are 0 to less than 5, and then 5 to less than 10. So 5 would go into the next category, not from 0 to the 5. All right. This part is explained, but it's easier to see it. This hopefully should make sense. And when we do it on the graph, it'll hopefully make even more sense. And this is what the counts look like. So on here, okay, so we found the count. There are 20 states that have from 0 to less than 5%. Okay, there are 20 states on here that have from 0 to less than 5% of their population is foreign-born. There are 13 states that have from 5 to 10, and so on and so forth. So I'm going to show you what one of them looks like, and then you can start to see what a histogram will look like. So look at the bottom. Okay, here's the number one difference between this and a bar graph. The bar graph had the states, for example, at the bottom. It would say California, New Mexico, Arizona, Texas, Nevada, and all that stuff. That would be a categorical situation for a bar graph. A histogram has the actual percentages. These are the number of states. These are your counts, and these are your percentages that you came up with for down here. So from 0 to 5, 5 to 10, 10 to 15, so on and so forth. So here, 20 would be the count between 0 and 5. Now, watch this because it looks very different. From 0 to 5. So I'm going to say, okay, from 0 to 5, I was at 20. So we're going to make a histogram, and it's going to look like that. Exactly from 0 to 5. Okay, so I stopped at 5. The next one would look like from 5 to 10, I'm at 13. So I'm going to go to 13 right over here, and then I have to drop down from 5 to 10. You cannot have gaps. No gaps between these. The only time you can have a gap is if you're actually missing data. So for example, if we were missing, there were no states at all that had between 10 to 15, we would skip this area here and then start up at 15. That's the only time you can have gaps. So for those of you that actually did your bar graphs and you had like spaces in between the actual columns or the actual towers or whatever you want to call them, you cannot do that in a histogram. It is not allowed. That's not the point of a histogram. Okay? So you have to keep going in. You have to just attach all of them together. And then let's see, the next one would be, what's the next one look like? 10 to 15 was 9, so we go up to 9, and then we do this part right here. So you just keep on building your towers, building your columns until all of them are filled in. Okay? The only time you have gaps is when you don't have anything here. That is a histogram. Okay? So the numbers on the bottom represent the percentage of foreign-born residents, right? And those are the number of states. Now, you can do counts, so how many of something that you had in a histogram, or you can take the same information and calculate the percentage of it. So, for example, 20 out of 50, so 20 divided by 50, is technically 40%. And you can do that with all of them. Basically, you're just doing, I guess you can call it a marginal distribution, but you're technically finding the relative frequency. You're finding the percentages. So each one of these is a percent. So 40% of your states were from 0 to 5, so on and so forth, up to 2% of your states were from 25 to 30. So you would do the same thing. You would say, okay, here's the, oh, it shouldn't say number of states. Oh, darn it, I forgot to change the scale. Oh, man. All right, well, I'm going to have to change this really quickly because this is not going to work out. This should say, this should say percents, number one, not. And I know that it looks weird because you have percent and percent, but trust me, that's just how it goes. Okay? All right, so that should say percent, and my scaling should definitely be different. I don't even know what to use for this. So let's go to, let's double up. So let's say this is 4, this is 8, this is 12, this is 16, this is 20. Oh, I'm sorry, not doubling up. I'm just going up by 4s. My bad. 4, 8, 12, 16, 20, 24, 28. Well, actually, I am doubling up. 32, 36, and then 40. Let's go with that. Okay. All right. So we basically just do the same thing. So for a state that had 40% of the states had between 0 and 5% of their population was foreign born. So you would say, okay, well, 40% goes up here. So I'm going to drop down my bars, and then we're done. Okay. And then you would say, okay, so 26% of the states had from 5 to 10. So from 5 to 10 would be 26%. And then we go here, and then we drop down. Now, what you will find is if there's one variable that you're actually measuring, no, I shouldn't say that. Usually, the counts and the frequency or the count, and the percent or the relative frequency, whichever you want to call them, but I'm usually going to say relative. I'm usually going to say percent. They kind of end up being the same. Or their shape, the shape of the histogram ends up being kind of the same. It just makes sense that way. Okay. All right. So here is your book's, here's your book's description. So percent of foreign-born residents. This is the number of states. Okay, if you finished it out, and this is base percentage of states. All right, and they should look the same. Okay, so the shape, the distribution is skewed to the right and unimodal for both of them, obviously. So you have a tail on the right side, so it's skewed to the right. Most states have fewer than 10% foreign-born residents, but several states have much higher percents. Okay, that's your shape. Your center, it says from the graph we see that the midpoint would fall somewhere between 5% to 10%. The center of your graph. So arranging the values in the table in order of size shows that the midpoint is actually around 6.1%. So the center would be, where is it so that most of your data is on this side and then the other half is on the other side. So in this case, if you actually go back to the original graph, which is about this one, you could actually find the center by putting all the data in order, finding that middle number and saying, okay, this is about the midpoint. So they actually did that for us, which is nice, and it's around 6.1%. But most of your data is going to be on the left side of kind of like this line right here, and then most of your other data is going to be somewhere around here. The number of these should kind of match the number of these. Your spread is going to be from 0 to what, 30? So over 25%, somewhere around there. I think the highest was 20 something. That's probably your spread. To find the center, why does it say this? Remember that we're looking for the value having 25 states with smaller percentage foreign-born and 25 with larger. So your center is kind of in the middle. So this many should fall here and this many should fall here. This should be pretty symmetric around your center. We don't see any observation outside the oval or pattern of distribution. It doesn't look like it has any outliers. It's kind of easier to tell if you have an outlier if you have a dot plot or a stem plot rather than a histogram. But in this case, it looks okay. All right. So some cautions, and then we're done with this. Several cautions. So when you're talking about comparing to, don't confuse histograms and bar graphs. The comparison ones later. So let's say we take the, what is this one? Percentage of foreign-born residents and radio station format. So this is probably a good one. So bar graphs come with categorical information. Always with categorical. You can't make a bar graph based on quantitative. Histograms is for quantitative. Okay, so when you have numbers that you're comparing. So percents, counts, things like that, that usually is what you want to do a histogram for. Bar graphs, categorical. Hair color, brand of shoe, histograms for things like the height of the people in the classroom or their GPAs or something like that, right? So those are the two. Okay. Several cautions. Okay. So the other thing is don't compare. So if you're comparing two things, this is really hard to see. I'm really sorry. When you're comparing something, two graphs of something, don't compare their frequency or their counts. You want to always compare their relative frequency or their percentages. So this actually says percent. And this actually says frequency, or I'm going to say counts. Okay, so if you're comparing two things, let's say in this example, I think they were comparing two magazines. And especially since in the first magazine, they took the first 400 words, and in the second magazine, they took the first 100 words. I don't know why they did that. But if one has, you're comparing 400 words, and then the other one you're comparing 100 words, you can't really compare the two things together because their counts are not the same. If you so happen to know that their counts are the same, then you could probably compare the histograms based on counts. But if they're not the same, then you have to compare it upon percents because percents are going to make things a little bit more balanced. Okay, so don't do counts if the what do they say here? If the two sets of histogram were another company fixed by using this one they're comparing. What was I getting to? Don't use counts if the sample size is different. That's what I wanted to say. So the sample 400 words versus 100 words, obviously it's not fair to compare those two. You didn't take the same amount of words. Okay, and then last is using histograms wisely. Just because the graphs looks nice doesn't make it a meaningful display of data. Okay, so even if you can make, obviously this is a bar graph because your columns are not attached to each other. Histograms have columns that are attached to each other. Okay, so if you make a bar graph like this, does it make any sense? I mean, just looking at it, you can't tell me that it's symmetric or skewed left or skewed right. Where's the center? Where is, what does the spread look like? And are there any outliers? It's kind of hard to tell, especially if it's what the shape is, and so then it doesn't make any sense to make a bar graph. Okay, so try something else. In this case, the dot plot on the right is a perfect example of what's going on in the bar graph on the left. The dot plot makes more sense now. It's not symmetric. Okay, it's actually I actually don't remember what this is called, but this is definitely not symmetric. Okay, so you can actually see a little bit better on what's going on. Okay, so summary in the last two videos. Interpret dot plots and stem plots. Describe the overall pattern of distribution. So we use the acronym SOX to describe it. And then identify the shape when we were doing that. That's the first one. Make and interpret histograms, and then compare distributions of quantitative data. And your check for understanding question, hopefully you can see this, but I'll zoom in really quickly. So there's a software program called Fathom, and it basically displays the number of siblings reported by each student in a statistics class. So the siblings, so each person basically reported how many siblings they had. So I guess one dot, because this many people had 2 siblings, this many people had 3 siblings, there's 5, and somebody had 6 siblings. So as your check for understanding on Canvas, I want you to describe the shape, right? Use complete sentences. Describe the center of the distribution. Where does roughly most of your data fall into? Like most of these things are here, and then the other half is here. Describe the spread. So from how many siblings to how many siblings, and identify any outliers if you have any, which I'm going to tell you right now you do. So you cannot just say you don't have any outliers. Okay, so answer 1, 2, 3, 4 in complete sentences on Canvas, and that will be your assignment for watching the videos. All right, have a good one.